When Tesla announced that its new chip would be installed in robots first and not in cars, the reaction was one of skepticism. Analysts questioned it, competitors ignored it, and much of the press treated the whole thing as yet another exaggerated promise from Elon Musk. But there's a detail in this story that changes everything. This chip consumes just 250 watts of power and delivers the same performance as a piece of equipment that costs $30,000. And this isn't a promise. The design has already been finalized. To understand what's happening, we need to start with a technical term that very few people outside the semiconductor industry know: tape-out. Tape-out is the moment when a chip's design is considered complete and sent to the production facility. It's the point of no return, no more revisions, no more adjustments. Tesla's AI5 chip has reached that point. It's real, and it's about to enter large-scale production. Manufacturing will be handled by two of the most advanced semiconductor facilities in the world. On top of that, Tesla is building its own chip factory in Austin, with a budget of $20 billion projected for a single year of operation alone. But what truly surprised the market wasn't the existence of the chip itself, it was its destination. The AI5 isn't going to cars first. It isn't going to the robotaxi that Tesla is preparing to launch. It's going straight to the Optimus Gen 3, the humanoid robot that Elon Musk has already described as the most valuable product in the company's history. And alongside that decision came a bold declaration. The target is to produce 1 million Optimus robots per year from 2027. Why robots before cars? To answer that, we need to confront an uncomfortable truth about current intelligent robotics. Most robots with artificial intelligence that exist today operate in a way that depends on external servers. The robot collects data through its sensors, sends everything to a central server, the server processes it and sends back the commands, and only then does the robot act. It seems functional, until the moment the network connection fluctuates, the server becomes overloaded, or the factory's Wi-Fi signal suffers interference. At that instant, the robot stops completely. In an industrial environment, that's unacceptable. An assembly line brought to a standstill because a robot lost its connection represents enormous losses every single hour. But there's a second problem, even harder to solve: energy consumption. To process complex tasks in real time, a humanoid robot needs a powerful chip. The most powerful artificial intelligence chips currently available, such as Nvidia's H100, consume more than 500 watts continuously and cost $30,000 per unit. A typical humanoid robot's battery holds only a few kilowatt hours of capacity. If the chip alone consumes 500 watts, the robot drains its energy within a few hours. And that's without counting motors, sensors, and all the other systems. In practice, the robot can't even complete a single work shift. That's precisely why no one had managed to build a truly autonomous humanoid robot at industrial scale. Not for lack of ideas, for lack of a hardware solution. Tesla found that solution. The AI5 was described by Elon Musk with very specific figures. Compared to the AI4 generation, currently used in Tesla vehicles, the new chip is 8 times more powerful in computational performance, 9 times larger in memory, and 5 times faster in data bandwidth. A single AI5 chip delivers inference performance equivalent to Nvidia's H100, but consumes only around 250 watts, half of what the Nvidia chip requires. 250 watts, that's the number that changes everything. With that level of consumption, the Optimus Gen 3 can operate for a full work shift in a factory without the need for constant recharging. And since all the processing happens inside the robot's own body, it doesn't need to send data anywhere. Every decision is made on the spot, on location, regardless of whether a Wi-Fi signal is available or not. Musk was direct. The AI5 will give the Optimus sufficient local intelligence to work even without a network connection, in the same way that Tesla's autonomous driving system operates in its vehicles without needing the internet. But what truly sets the AI5 apart isn't just the numbers. It's the design philosophy behind them. Most artificial intelligence chips on the market, including those from NVIDIA, were designed to serve many customers with many different types of tasks. That flexibility comes at a cost. The chip carries components that Tesla would never use. Tesla did the opposite. It removed everything that was unnecessary: conventional GPUs, independent image processors, modules dedicated to functions that Tesla's neural networks never perform, and directed all of the chip's area and all of its power budget towards a single thing: running Tesla's neural networks as fast as possible. It's the same philosophy that Apple applied when it migrated from Intel chips to Apple Silicon. The result was MacBooks with double the battery life and far superior performance. Tesla is following exactly that same path, but applied to robots. And the result is a chip that, in Musk's own words, costs a fraction of the price, but delivers performance equivalent to $30,000 worth of hardware. Now comes the part that few competitors can replicate, regardless of how much money they have. Before the Optimus sets foot in any factory, before it collects a single second of its own data, it had already inherited the entire visual knowledge base from more than 4 million Tesla vehicles traveling the roads of the world. That's 8.2 billion miles accumulated under real conditions: sunshine, rain, darkness, motorways, narrow alleyways, unexpected objects appearing out of nowhere. All recorded, processed, and incorporated into the training of the neural networks. That's an advantage you can't buy with money. Boston Dynamics has more than 30 years of history in robotics. Other companies in the sector are building their datasets from scratch. Tesla starts with 8.2 billion miles. But car data is only the foundation. The Optimus still needs to learn to use its hands, something a car never does. Tesla solved this in a practical way. It sent engineers to its factory to film real workers carrying out their day-to-day tasks. Not to program robots, simply to observe and record human beings. The way a hand grips a small part without dropping it. How the body automatically adjusts its balance when carrying something heavy on one side. How the eyes scan the environment before entering a tight space. All of those natural movements which humans perform without thinking were incorporated into the training system. The Optimus learns by observing humans, just as a child learns to walk by watching adults, without anyone needing to explain it in words. And Tesla is developing this a step further. The ability for the Optimus to learn tasks from videos available on the internet. Showing the robot an assembly tutorial could be enough for it to understand and carry out the procedure on its own. It's still in development, but that direction reveals a great deal about the company's long-term ambitions. There's yet another layer to this story. The Optimus doesn't only train in the real world, it trains in a world created by artificial intelligence itself. Tesla has built a system called a neural world simulator, an environment generated by neural networks trained on billions of hours of real video, capable of creating entirely new scenarios with completely realistic appearances. Variable lighting, randomly moving objects, unexpected situations that no human could anticipate. Inside that simulated world, the Optimus trains thousands of times, fails, learns from its mistakes, and tries again. At speeds hundreds of times faster than reality. No risk, no damage, just learning. This brings us to what Tesla calls the fleet flywheel. The flywheel effect of the robot fleet. The mechanism is straightforward. Every Optimus working in a factory continuously collects data. That data is sent to a central system, processed, and the lessons extracted are incorporated into updates to the shared AI model. The update is then distributed to all robots via the network, exactly as Tesla sends software updates to its vehicles. One robot encounters a difficult situation and works out how to handle it. A few hours later, the entire fleet knows how to do the same. And as the number of robots grows, from a few hundred to a few thousand, up to 1 million, the learning speed of the entire system increases exponentially. Not linearly, exponentially. For that flywheel to work, two things are needed simultaneously. A chip powerful enough for the robot to process locally without bottlenecks, and a fleet large enough to generate a diverse and meaningful volume of data. Tesla is building both in parallel right now. And here is the central point. This advantage compounds over time. More robots generate more data. More data produces a more intelligent AI model. A more intelligent model allows the robots to do more. More capable robots mean more sales. The cycle continues, and the gap between Tesla and its competitors widens. But it would be dishonest to speak only of the positives. The first truth that needs to be stated: the gap between announcements and reality is still significant. In the fourth quarter 2025 earnings call, Elon Musk himself acknowledged that the Optimus robots operating in Tesla's factories are there primarily to collect data and learn, not to generate real economic value just yet. He himself described it as a research and development phase. When the media talks about 1 million robots by 2027, many interpret that as 1 million robots functioning with human-level efficiency. The reality is 1 million robots manufactured. The actual operational performance at that point is an entirely different story. The second truth: the AI5 isn't going to the Optimus immediately. The chip completed its design in April 2026. The first engineering samples are expected by the end of 2026. The robots currently operating in Tesla's factories are still running on older hardware. The large-scale integration of the AI5 into the robots is a story for 2027 onwards. And the third truth, perhaps the most important: the competition isn't standing still. Boston Dynamics has decades of experience in robotics. Other companies in the sector are receiving investment from technology giants and have contracts in place with major retailers. And Chinese companies are manufacturing humanoid robots for a fraction of the Optimus's target price. They don't have the 8.2 billion miles of data, they don't have the fleet flywheel, but they have an advantage in cost and speed of commercialization, two things that the mass market values enormously. Tesla is playing a long game. The real question is, will the market have the patience to wait? And will competitors manage to close that gap before the flywheel gains enough speed to become impossible to catch? The fleet flywheel is Tesla's true competitive advantage, not the chip, not the robot's design. Chips can be copied, designs can be improved. But 8.2 billion miles of real data accumulated over years, combined with millions of robots learning in parallel, 24 hours a day, that can't be built overnight. That's precisely why Tesla prioritized the AI5 for the Optimus over the cars. The AI4 is already good enough for the vehicles. What the company needs now is to activate the robot's autonomous learning cycle as soon as possible. Every month of delay is another month the flywheel isn't spinning at full capacity. When it reaches sufficient speed, it will be very difficult for anyone to stop it. 1 million robots, self-learning artificial intelligence, a chip more powerful than $30,000 worth of equipment. All of this is happening now, not in a science fiction film. If this content made you think, share it with someone who still knows nothing about this subject. It's the best way to support this channel. Leave a comment if you see an angle that wasn't covered here. And if you haven't subscribed yet, do it now. There's a great deal more to come.